Good morning all. Now let us see the design thinking based speech signal processing. See, signals and systems is the modern tool for basic communication systems. See, signal, what does mean by signal? It is the one or more independent variable that contains some information is called as a signal. See, in this speech signal processing, we are going to analyze different types of transforms, how they convert from time domain into frequency domain analysis. So it is used in the speech recognition, it is used in wide number of applications, including voice assistants such as Alexa and Google Assistants. Now, design thinking stages is of 5 stages: empathy, define, ideate, prototype and testing. Let us discuss briefly.
I am going to talk about empathy. The empathy is users understanding the user and the environment. The user starts to have the voice commands more quickly and respond without the noise in the environment. And the challenges are misinterpretation due to accents and dialects, and the noise should be avoided. And the other one is delay in the organization. Signal and system perspective. Speech is a non-stationary, so it changes continuously over time. And the other one is system must identify the noise and the speech differently by avoiding the noise in the background.
I'm going to talk about the define of the problem statement. An actual problem statement is to design a voice assistant which can recognize the signal reliably in a noise and in the real-time environment. The sub-problems in this are accurate detection of representation of signal in frequency domain, filtering of unwanted signals and noise cancellation, and fast and reliable signal recognition under real-time constants. The signals and system tools are first sampling theorem. It chooses the suitable sampling frequency. Second is filtering, FAR-IAR filter, which reduces the noise and echoes, modulation and demodulation techniques for wireless communication of speech recognition.
Now let us explore the ideas of it. Let us explore the solutions for speech recognition. We want clear speech and better recognition. So first, we use noise reduction, where we use adaptive filters to learn and remove noises from the speech. So it makes the speech clear. Next, we use spectral subtraction, where we subtract constant noises from like fan noise from the signal. Then we use feature extraction, where we use MFCCs to capture how humans hear. Then we use pitch and phonons to remove, to find voice tone and vowel changes, and by using Fourier transforms. Then we use zero crossing and energy, where we detect speeches from where it starts and where it ends. Then we use system adaptation, where we use echo cancellation to cancel echoes in the room. Then we use multi-speaker handling to search voice in group talks. Then we use AI learning. The system gets and learns your voices by recognizing it. Then we use various optimization techniques. First, we use FFT for faster frequency analysis. Then we use DSPs for real-time speech processing with no delay.
And the next problems to solve in speech recognition are noise cancellation and filtering of unwanted signals, and then fast and reliable recognition, and then representation of speech in terms of frequency domain. What are all the tools we are going to represent in terms of speech recognition signal is sampling theorem. See, sampling is nothing but your process of conversion of analog into digital, right? It measures the sampling frequency, and also Fourier and wavelet transform. It is the representation from the time domain into frequency domain, and then filtering, which can reduces the noise and echo, and modulation and demodulation for wireless communication purposes. Adaptive filtering, by using LMS algorithm, we can going to analyze the speech signal processing.
I am going to brief the prototype. The prototype defines initial testing and building initial systems. System signal capturation. You can capture signal from the outside to high quality microphones. Pre-processing. Captured signal is applied with a bandpass filter to suppress unwanted frequencies. Framing and windowing. We captured audio signal is converted into smaller ones. Transformation, apply FFT or Fourier transformation to the captured audio signal, and feature extraction, compute MIFC or pitch and recurrent values to it. Recurrent algorithms uses CNN convolution neural network and RNN recurrent neural network and DNN deep neural network using it.
I'm going to talk about the testing. After developing the prototype, we need to test whether it works well in real time. Here we are testing it in two conditions. One is in a silent room and next is in a noisy street where people keep on talking. And here we are going to check three conditions. First one is accuracy, that is how the system capture the words, and next is speed, how fast it reply to the command, and next is noise cancellation, how it catches the words even in a noisy environment. After testing, the user give the feedback like it didn't catch my accent, or it did hear me well in a noisy place. After getting the replies from the user, the engineer again fixes the problem and tests it again, and this cycle repeats until it works smoothly.
So let me conclude the topic. So design thinking keeps need at the core of speech signal processing. So empathy, define idea, prototype testing ensures practical implications. It combines noise reduction, feature extraction and real-time system design. So it merges signal processing theory with human-centered design. So it produces reliable, adaptive and user-friendly voice assistants. It bridges engineering with the everyday life, making technology socially impactful.
And then now let us conclude the speech signal processing. See, what are all the tools already mentioned in here to analyze the speech signal with the help of sampling theorem, modulation, demodulation, that is wavelet transform and fast Fourier transform for signal analysis from time domain to frequency domain. What are all the building and testing for speech signal processing is, first you are going to analyze the signal acquisition, pre-processing, transformation, future extraction and signal integration. What are all the metrics to be followed in speech signal processing is latency, accuracy, SNR improvement and robustness. See, with these all metrics that Fourier and Laplace transform and its modulation, demodulation by using filtering techniques, IAR, filter, FIR, filter, multivariate signal processing. With all these signal processing applications, we are going to handling the real world challenges in speech signal processing. Thank you all.